Hi, my name is Bettina Spadin and I'm a senior client executive at Microsoft in the manufacturing area. It is a great pleasure to have Professor Marc Pollefeys here with us, leading expert for computer vision and mixed reality and AI, discussing today the topic about trends and challenges in AI. Warm welcome, Marc.
Thank you, Bettina. It's nice to be here.
Marc, you are currently working as a professor at ETH in Zurich, and you are leading the Computer Vision and Geometry Lab. You're also working at Microsoft in the role as Director of Science at the Microsoft HoloLens. And since 2018, you're also leading the Mixed Reality and AI Lab here in Zurich. Looking at your great resume, it seems that you always have been passionate about computer vision, AI. Can you elaborate a bit? What have been your motivation to start this field from the very beginning? And maybe as well reflect a bit how it evolved over the last 30 years.
Yeah, so indeed I started my PhD about exactly 30 years ago. At the time we were not at all where we are today. Computers were a lot slower. In a sense, I started in the field by chance. I always liked geometry and math and these type of things, and computers and so on. And I had the opportunity to start a PhD in the field. We were not at all this far. Back then, it was people would try things on 1-2 images and get some results, and it would all be limited. But there were lots of open areas, open questions. And so I was interested really in, can we use images to extract, so computer vision is about extracting information from images. I was in particular excited about extracting three-dimensional information from images. So to be able to, we take images of a 3D world. We live in a 3D world. And so can we, from just 2D, flat 2D pictures, can we extract three-dimensional information from that? And so that was something we had very limited capabilities back then. And so that's what I started looking at. And so we started getting some very nice results to be able to do this step by step, fully automatically, being able to do that even if we didn't have to precisely calibrate the cameras in advance and so on. So we could just go out, take pictures, process those pictures, and have automatically a three-dimensional representation of what was seen in the pictures reconstructed. And so it turned out that back then we're the first to, in a sense, put it all together and be able to go out, take pictures, and then have algorithms take over. And at the output there was a nice visual three-dimensional representation of the world. Now this was still all quite slow, quite brittle, etc. But then over the years, this has become more and more feasible. Eventually, we could do this on a cell phone. We could do this in real time. We could do this at the scale of a city, etc. And so there's been lots of evolution there. I would say in the 90s, in the computer vision field, there was a lot of progress on this aspect of being able to reconstruct the world and extract this geometric information from images. So one aspect of computer vision was reconstruction. The other aspect was trying to recognize things, to extract semantic information from images. Back then, this was nowhere. It was very limited. And then in the early 2000s, people started looking at, can we bring machine learning techniques to computer vision? Computer vision was always part of the AI field, but they wasn't necessarily very close to the other machine learning techniques and wasn't really leveraging those techniques. Then gradually, this started kind of evolving. The results were still that field was still struggling. It was all hand-tweaked kind of methods. They were not getting good results, I would say. But then around the 2010s, early in the 2010s, a few things came together. There was, on the one hand, people worked on data sets. in particular Fei Li with ImageNet, assembled millions of images, labeled, said in this image there's birds, and in these images there's cars, and in this image, and so labeled a huge data set of images as a challenge for the field. People had been working for a very long time on deep neural networks, but were struggling because they were struggling to get beyond very simple problems like recognizing characters or very simple small problems. The combination of the advent of these large data sources was one element, but then the other element was the graphics processing units. Back in the early 2000s, the graphic processors became programmable, mostly because in games people want to do fancy effects. But gradually, by making them programmable to make, so NVIDIA started making them programmable to make more cool effects and to be able to program your own effects and so on. People start realizing, hey, we can use these computers that are, in a sense, much better. This was a time where CPUs were starting to struggle to keep up with Moore's Law. Moore's Law was proposing, was doubling the number of transistors on a 2-year cycle or so. But there was a struggle on how to use that, how to keep using that to make computing faster. Because if you do sequential computing, one operation after the other, they were essentially using all of these extra transistors, mostly wasting them on cache and on a number of different things, but they couldn't really accelerate a single sequential program with more transistors. You could do many more things in parallel, but you couldn't accelerate. So CPUs were really struggling. They became multi-core. The clock frequencies couldn't go up anymore. They had to do multi-core, but then you had to make them parallel programming. There were lots of challenges. CPUs were starting to struggle and hit a little bit of a slowing down in how much they could absorb these gains from Moore's Law. While GPUs could fully take advantage, because they're massively parallel, could fully take advantage of the continued progress of Moore's Law and of having more transistors available. And so that's really where GPUs started becoming more and more powerful compared to CPUs. So people also started to look at this as they became programmable. Can we use those to do other things with it? We actually did work in 2003. We published work where we were starting to do, actually, one of the first ones to do more advanced computer vision algorithms, in that case also to extract 3D information from images, on GPUs and leverage the parallel capabilities. Fast forward to 2012. That's when essentially people started looking at training deep networks, so AI, on deep neural networks on GPUs. And as they suddenly had this large data collection was available, that combination, those two elements coming together on GPU, so the GPU compute plus large collection of data, enabled to suddenly get really good results there. And actually showing that if you trained everything end-to-end, your whole pipeline from images to results, where you have both sides, and then you train a function that can reproduce the results that you kind of give it, that this was essentially beating the state of the art by a significant margin. And that's where everybody started paying attention. And the whole field pivoted to work on deep networks and push that further forward. And that's where we've seen then a huge evolution and led to actually what we see today. So both in vision, but also in speech and natural language processing, deep networks became essentially the de facto method to use. And so in these different fields together has essentially led this huge evolution, which brought us where we are today in AI.
Wow. I mean, that's fantastic. And I could listen to that for many hours because it's really amazing what happened in the past, but I'm also sure we keep on this pace in the future. So what would you say? I mean, how this fast evolution of AI capabilities also impacts your way of research in the field, for example, with your work on ETH, but also at Microsoft? So
there's two impacts. So one that's interesting, the fast evolution in the computer science field also, or in the machine learning field and computer vision field, together with the fast evolution. So a big part of why there's such a fast evolution. So first, the hardware is really charging ahead very, very fast. But what we also see is that the field has, when I started, everybody was, developing their own algorithms and keeping them to themselves. And so if I had a really strong algorithm, others couldn't really use it. And so that made progress slow because, you had to first rebuild, like read somebody else's papers, re-implement the methods. If you wanted to combine a few methods, you had a lot of work before you could actually start the new work, new research. Nowadays, it's a de facto standard in the community to share your work. There's also a lot of frameworks in place that make it easy to share the work and so on. And so it's now default to share your data, to share your algorithms, to share your neural networks, and so on in the research community. And so that means that now you can very quickly take a few elements, combine them, retrain them, do things. So there's so much infrastructure that allows us to really move very quickly. And then, of course, in terms of publishing the results, there's, instead of having every 6 months a conference and kind of you only know about somebody else's work at the 6 months kind of, let's say, clock cycles in a sense, now people put their early results on archive, on public kind of accessible, share it much more quickly, and so people can very quickly work on each other's results and so on. So that has led in the research community really to, in addition to, of course, what everybody benefits from these powerful tools, from being able to train large networks, do a lot of things, the fact that we exchange so much in the research community has really allowed the progress to accelerate tremendously.
I love this to hear. I guess this is also the way how you can cope, you and your research team can cope with this fast pace, or how do you ensure that you are ahead of the curve or not missing out something?
Well, in research, I think it's important to look at, to keep the focus on the actual problems and challenges of things that don't work yet. A lot of junior researchers, they hear about some great results somewhere, and then they flock towards that, and many do, and they flock towards that, and they try to do, to improve that thing, like this best paper, or something at a conference, or this kind of new method that came out. They all want to work on the same thing. That's then it's a struggle, because by the time you have your idea and you work it out, somebody else has published the same idea, and you are scooped, and then you kind of wasted your time or so. And so that's difficult to stay ahead if you really are always trying to kind of work in the same small area. So I think it's more important to keep focused on actual problems, on actual challenges, on trying to make something work in a real scenario, in a real case. And then, when you actually try these, supposedly best methods and this and that, and you try them on concrete problems, on real world challenges, you very quickly realize that the methods are not yet actually solving the full problem, or the problem on a representative set of data, as opposed to just a limited benchmark. And so when you then try to actually solve the problem, then along the way you are solving plenty of interesting research problems. And so that's the way that I try to kind of push research.
Really interesting. And you already said or talked a bit about challenges. So could you maybe elaborate a bit more? What are typical challenges you currently face in your work of research, but then as well maybe on your area at Microsoft? Are there similar challenges? Are these different challenges? And how do you try to address those?
Well, in a sense, there are still many things we cannot do. When people talk about, now computers have achieved, human level capabilities in this or that area or so, what they actually mean is, on this particular benchmark data set, we've been able to really train our system to do as good as a human that's kind of presented with this data. For example, images where you're supposed to say, what are the objects in this image, or things like this. Now, if I present you a number of images and you just look at them and you have to say things, well, you might not know everything. There might be, some categories that you're not that familiar with, special types of birds, or I don't know what. And so you might not do a perfect job on this. Also, it's very different to look at a small image and as a person and, kind of have to recognize everything, as opposed to walk around the real world and kind of be able to recognize what's relevant to you. So in the if you look at this narrow case of showing images and saying, identifying the objects in there and so on, like in specific scenarios and on specific data sets, computers can be trained to do better than humans. If you actually go with that in the real world, and now you just take random pictures in the real world and you see how well those supposedly better than human networks actually perform, you very quickly see that they are actually still nowhere near. They're getting better and better, and they're now at a level where they actually, can produce useful results. But it's not that they are systematically better than humans or anything close to that. So I think there's still a lot of challenges ahead of us, especially when you're thinking of real deployments in the real world. Now, I think what's been interesting is that in terms of what I've seen in the last 2 years, what we've seen is that we've certainly achieved kind of a breakthrough, let's say, on the level of conversational interactions. So being able to converse in a natural way with a digital agent, a copilot or so, that's been something quite amazing to see, and that certainly opens up, I think, very nice opportunities. It allows to have completely new form factors of interaction and so on, I think, and so that's certainly very exciting. And so now we can kind of explore what's possible there and what makes sense and what is useful to people also.
No, absolutely. And I mean, talking about trends and opportunities, where do you see the biggest trends or opportunities of AI with this much better computer power we could see? And maybe if you could share some use cases, I don't know, spatial AI or in the area of mixed AI, mixed reality, which are super interesting.
Yeah, so I think, what's really shown up in the last few years and has kind of also changed my thinking of what's possible is really this ability to exchange information with a computer through natural conversation. And to essentially, it used to be that you really had to, interact with a computer in a very structured way. Like with tables or with kind of information, you had to fill it in the right form and then it would work. But if you would formulate things a little bit differently and so on, then very quickly confusion would ensue. And it would kind of somehow get stuck. Now, what we've seen with these large language models is that they enable really a much more natural interaction. You don't have to, say exactly what, like very precisely find the right words or remember the right commands or things like this. No, you can actually just converse in a way that you would converse with a person. And, this kind of works quite well. There's still confusion and there's still, things that don't work perfectly, but it's at a completely different level. It's at the level where you kind of, it's past a threshold where it's actually, it feels natural, it feels comfortable to kind of interact with it. Now, what does it mean? It means that now, instead of needing, for example, in mixed reality, it means that it opens the door to exchange information and to interact with information, to access information in a completely different way than before. Now, it's still all based on actually what information can you provide. I think, in particular in spatial computing and mixed reality, there's still a challenge if we want to assist. So the scenario that we are focused on at some level, right, is to be able to, for example, assist people, for example, in manufacturing, frontline workers that are walking around the factory and have a job to do. More and more also with the challenges of having enough expertise, having the right people in the right place. Also, even if you have them mostly in the weekend, not everybody might be around. That's needed. Something happens. You need to solve a problem. Being able to, what you want is to be able to then ask someone for help. If you don't know the solution, you have a problem, you don't know the solution, you want to ask for help. Okay? In mixed reality, what's worked the best is also called remote assistance tools. So with the HoloLens, for example, or today also with the phone or so, you can kind of you can call up someone, you can show the problem, and then they can kind of help you solve the problem. So if they have the expertise, they can point out things through mixed reality. You can actually, in a very intuitive way, point out. You can visually overlay on the world, like it's this button, and then you do this, and then you do that, and you can visually show that. It used to be that visual was strictly required to do anything. Now you can actually also do a lot of things through just a voice interface. So that, relaxes a little bit when you need mixed reality. There are still many cases where mixed reality, like a full mixed reality immersive device, will allow you the best, like the most effective interactions. But you can also, in a sense, in many scenarios, you might be able to solve a lot of problems just through voice interactions. So that opens the door to a much wider field of applications. Because you don't necessarily need to have your fancy, expensive mixed reality device with you, but you can also do many things just with the phone, or in the future maybe with, just a device that is equipped with a camera and some audio communication. So I think it broadens very much the kind of the field in which you can apply this. Now, one thing is I was saying remote assistant, so there's no AI involved in that. However, many of those questions might actually be relatively basic questions that person happens to not know, but that is well understood and well documented and has been, in many other sessions already discussed many times over. So if that data exists within that company, within the thing, then you can actually, that's where we can leverage AI methods to organize that data, to extract the right relevant information and present it to the person, maybe without needing, to wake up the expert or to have to bring in the expert. Or maybe you bring him in when it really gets complicated, but for all the easy cases, you don't have to bring in the expert, meaning that you can actually really increase the productivity of the expert because they only have to come in when they're really necessary. But in most simple cases, you can actually just tap into the data that's available, and but with AI techniques, actually extract the right and relevant information, presented in a simple way to the person. Now, the keyword there is relevant information, the right information. As we know, there are challenges with large language models and so on, that they can hallucinate, like there's a problem of hallucination, there's a problem of, you ask them something, these networks will just kind of look and find somehow the closest, whatever, they will come up with something, independently of them actually knowing the answer or not. They will always give you some answer. That's where the challenge is, you're finding the relevant information. So you have to ground the answers in the right information, in a sense. That's also where we've seen at Microsoft the success of much smaller language models, because those have been trained on curated information, on much more limited information, but all the information has been validated and verified. It comes from textbooks, it comes from things, so it's solid information. It's not like whatever random stuff people talk about on the internet, somehow all put together and then just pick your answer from it. It's actually, that everything that's in there is precise. So similarly, the same concept is that if you are in the factory, which is of course a three-dimensional space, a very complex three-dimensional space with many different things, and for everything that's in there, there's lots of relevant information associated with this machine and with that machine, and with, on this machine we've done this maintenance and all of these records. And with the rest of the digitalization, we have IoT devices that are connected to that machine and form a source of relevant information. If a technician needs to do something, or if there's a problem showing up, then you can look at it, at all that time series data of the IoT sensors and all of the rest of that information. But the key is, can you actually, have access to the right information? And so, because it's all existing in a three-dimensional space, and that's where spatial computing comes in, spatial intelligence comes in. You want to be able to organize your data spatially in the environment. You want also, as people walk around, and gradually more and more, now they walk around with a camera in their pocket and take it out when relevant, when they need it. But I expect that in the coming years, we'll see more and more people, one way or the other, walk around with cameras that are kind of always available. On their glasses, on a pin, or whatever. And then more and more information will be collected, especially in these industrial spaces. in public spaces, there are all types of privacy questions, in that space. But if you're in a manufacturing hall and you're doing your work, everybody there is doing their work and focused on doing their work. When I do maintenance, when I do this, when I have to assemble a machine, if all of this can, at no cost essentially, be also documented, and if something happened, something went wrong, you can actually go back and check it, that opens up a lot of possibilities. And so that's what I expect to see. Now, if you do that, you want to actually be able to organize and structure all of that data and structure it and align it to the 3D space in which it's actually happening, right? So that's really what we're focused on with my team, and so is to build a platform that enables to bring all of this data together that's collected in a very unstructured way, structure all of that and place all of that in the proper spatial or like in a proper 3D space where it's been recorded at the time it's been recorded. Have all of this become essentially available to then the AI agents, the copilots, to essentially answer questions of people, or to afterwards, figure out what happened when something went wrong and so on, to be able to have all that data essentially available and structured.
Oh, absolutely. And I mean, just listening to what you were just saying, I could imagine that there will be so many customer use cases solved with what you were just describing, and very curious to see how quickly those capabilities will be available and adopted in Microsoft products and processes, obviously. You also talked about the responsibility of these capabilities, right? So what do you believe, what kind of implications will we have across the society and the industry, and how do we prepare for this change? Because it's change in the way we work, but also it's a lot of change from adoption and perspective, let's say.
I mean, that's a big question, and there's lots of different aspects to it. I think the key is I think we'll have to find a way to do it in a sense a little bit more what the small language models, I think what they've shown kind of is that, it's the usual thing. It's garbage in, garbage out. So we need to make sure we don't put garbage in, because those systems will be leveraged on more and more. They are great tools that can help us in many things, but we shouldn't take it too easy. We shouldn't just push everything we can in it and assume that, when we train it, the consensus will be the right thing. Because so essentially with these networks, what they will do is they will kind of take all this data together, and then when there's in areas where there's many answers, many examples shown, like there's like topics that are discussed many times over, where like in, let's say, on the internet or wherever the data sources are, those you'll kind of essentially get the consensus answers kind of coming up, and then with the right prompting you can kind of explore the side answers and this and that. So there's a problem there. Is the consensus the right answer? Is that what you find on the internet? We all know this is not always even the majority kind of what you find might not be the right answers. Like there might be, if you ask random medical questions or so, what you find mostly online might not be accurate. So obviously there you want to somehow find ways to get, I think in a sense we might see a little bit the return of the people might realize that the information provided by experts is actually important. I think we'll see some of that. So I think we'll see more research or work in finding better ways to create things, to find what is actually the right answers, the thing, not just take whatever is there and give that back to you, which is in a sense what search engines have been doing today. They've tried to find the more relevant answers, but there's been a real struggle there, and of course there's been a challenge of combining kind of commercial interest with commercials, together with then also trying to be useful to you, but mostly also make money, by selling like your kind of attention to someone else and so on. So that does all make it, and so I think that's I would say the early days of, let's say, when Google started or things like that, it was probably in a sense, there was less information available, but it was able to better hone in on the right information. Now it's a bit kind of, and I think with large language model, all this technology, we're kind of starting at the same point and risk of of essentially of struggling to provide somehow not everywhere, like in many places it does give the right answers, but in other places like we'll see struggle, and we might see more and more struggle because people might try to inject, find ways to also inject the things they want to have in there. So I think we'll have to find the ways to, it will be really important for society to find the right ways to create information to do that. With of course the question, if you create, is it also, somehow are you starting to bias, what people see? So there's two sides to this. I think it will be important to bias, but you want to bias in a good way, like towards the right answers. But we all know this is controversial, and not everybody will agree on what should be the right answer, and so on. So I don't know exactly, but you can also not just throw random things there. So I think there's going to be a challenge for society to figure out. That's in a way where I'm happy that I can focus on a place where there's much less controversy. I want to help people in manufacturing, in the front line that have to do their work, and there it's not very controversial what they have to do and what the right answer is and this and that. There's much more objective, solutions there and so on. So I think we can, in a sense, we have more opportunity to focus on solving the technical problems without having to necessarily take on all of these much more complicated questions around ethics, around other things. Is something that we can that we are not forced to take into account right away. So that's something I like about being able to focus on a place where it's more a tool, and it's something that has not these privacy implications, these societal implications, and so on. I mean, there are also societal implications, but different. Sometimes you hear people like, is this going to, many years ago, it was more about, well, what about, is this going to replace workers? Is this, and so on. I think in the meanwhile, we realize that there's more because of the demographics and so on. We realize that actually it is important to be able to continue increase productivity because of demographics. Otherwise, we will have to take a step back in what we can do.
Yeah, fully agree. And I mean, worker shortage is definitely a challenge in the market, especially in the manufacturing. Also, that certain knowledge will go out of the workforce, let's say, due to retirement. So I think it's definitely an opportunity.
I think that's where there's a huge opportunity
for the
AI.
industry. Fully agree. Marc, last question from my side. We have heard the transition over the last 30 years. There is a lot announced almost every day. Let's imagine 5 years from now, where will we be? As you were saying, will we have smart glasses? Everybody's wearing, instead of corrected glasses, smart glasses or lenses even. Or do we have, I don't know, assistant in our ear? What would you envision?
So I'm not I'm not sure the form factor. I think smart glasses is probably a good bet. I think there's huge opportunities there. I think, Satya, when he saw some of the things that we're working on in mixed reality and so on, I think he kind of coined it very nicely. He said, these are the eyes and ears of AI. So essentially, and I think in a sense that the mixed reality part of it is on the display side of how you then show what the computer interprets back to the user. But in a sense, that's even, that's in a sense optional in a sense. But I think the possibility to have, currently on demand, you can take out your phone and take a picture and ask a question about, you can essentially provide visual context to AI to kind of, to better answer the question. So that is something that I think will one way or the other. Will it be a camera pin? Will it be, like in the manufacturing, will it be a camera on the helmet that becomes default, the hard hat, or does it become, like a camera on a kind of frame, or is it a body cam? Is it, etc. I don't know exactly what form factor it will take, but I expect that this will, over the next 5 to 10 years, will go from almost, only in some specialized jobs like police, for example, have body cams, right? Because it's important to be able to check afterwards what happened when something goes wrong and so on. But I expect that as the price of these things come down, in particular, not only the price of buying a camera, but the price of having this deployed, managed, store the data, all of the other things, and be able to extract useful information from the data. As those things, progress and come on, the utility for this will greatly increase. And so I imagine it will go from like this being the exception of people walking around with cameras, to this becoming, like much more standard, to eventually having essentially pretty much everyone that walks around in a factory, have a camera with them and document. Think of what happened with Boeing, for example, where, like somebody forgot and they don't even know exactly what happened and this and that. If that person had a camera and everything was recorded, it'd be very easy to answer that question. If you have AI that can look at this, AI could say like, hey, like something was forgotten there. Let's make sure that this gets sorted out before we send out the plane, right? So I think this will just naturally come, I expect. The question is what happens in broader society and so on. I think there is a lot of potential for that. I think we already see it from some of the glass manufacturers. They are pivoting from, recording your stories and stuff like that to actually start also providing AI assistance on these form factors. I think it's very natural. If you can ask questions and at this, in the context of the visual, by providing, like letting the AI access your visual context, your context essentially, and we extract most of the information from the world from our visual sensors. Half our brain is dedicated to processing, what our eyes see. So obviously, it's useful and it helps us really interact with the world. And so I think it's quite obvious that AI will also have that. And so I think this will become, much more pervasive to have, cameras that are not necessarily always on, but, can always essentially kind of be switched on to provide context and answers. Now, this does come with all kinds of implications and questions, and it will be interesting to see where we get a consensus and how this evolves or so. But I'm pretty excited to see what will happen there.
Yes. Hey, and I'm pretty excited to hear again what happened the last 30 years. I'm very excited to hear what's coming next. So we will stay tuned. Thank you so much for your time. And
well, thank you.
Let's stay in touch. Thank you so much.
Yeah.